I think so. Problem is that everything you demonstrate in a single center in a non-randomized fashion is not as strong as a multi-center randomized study, of course. But if you look at our experience, yes, it's pretty clear that it helps and it makes a difference. And so typically our recurrence rate, since we moved to image integration, has been reduced by a factor 2, so twice less recurrences for our VT patients after ablation. And something that is quite spectacular is the impact on the procedure duration. Now, this depends on how you use image integration. There are different strategies. Not all the centers are using them the same way. And so I don't know, maybe Hubert, you can take me to those slides now, because we have this question where we show the strategy. So what we thought, here in Bordeaux is that, for years we've been, comparing our 3D maps showing the substrate from mapping with multi-electrode catheters to the information we've got from images. And it became very clear that in fact we had the same type of information. It's probably even more accurate when we use images, because there is it allows you to see what is happening in the wall thickness as compared to a mapping that is purely endocardial or purely epicardial, in where you have no insight on what is happening inside the LV wall. And so here, what we ended up doing in Bordeaux is that we have our color-coded map for wall thickness. Again, the dark red that is contoured in white here is the most dense part of the scar, because the wall thickness here is 1 millimeters. And then it goes all the way up to the bright yellow that is 5 millimeters. So the idea is that these dark red areas are very unlikely to play a role during VT, because their conduction properties are just too bad for that. And so the slow conduction area that sustain the VT circuit is more likely to happen in areas where there is a little bit more wall thickness, so that there are probably not just fibrosis, but also surviving bundles of muscle. And this is in the 2, 3, 4 millimeters range, where we draw these green arrows, as you can see here. So these are what we call CT channels. And then our strategy in Bordeaux is that we don't map with any diagnostic catheter. We no longer use multi-electrode catheters. We just fast map the aorta or the pulmonary arteries for registration purpose, as said before. And then we would take our ablation catheter directly to the images, to the CT channels. And we deliver energy there to block them. We make sure that we lose capture here. We pace after ablation at 10 milliamps and 2 milliseconds, make sure that there is no capture. And we manage to place the lesions in the thinnest part of the CT channel. Why are we doing that? Well, because we want to maximize the chance for a durable lesion. So after doing that, and only after doing that for all CT channels, we would check for inducibility. And so by doing so, the other positive aspect you can use to discuss with your administration in your hospital to justify the extra cost is that the procedure, the VT ablation procedure, if you follow this approach, is going to be very short. It's less than 2 hours as a mean, and the standard deviation is very short as well, 25 minutes, meaning that you have no bad surprise here. You pretty much know that your VT ablation case is going to last 2 hours. And so from a planification and efficiency and lab time, these are, I mean, things that a hospital director can understand. It means that you can have an extra pulmonary vein isolation, whatever procedure. And so from a cost issue, it probably makes sense.